Okay, welcome back. We're going to be starting on the generation of electricity, but before we do that, I want to take a look at this short clip and review the renewable sources of energy. We're going to take a look at some of the renewable sources.
There are many sources of the energy we use every day. These sources of energy fall into two groups called non-renewable and renewable resources. Renewable energy resources can be replaced, and in some cases are considered to be limitless. Examples of renewable resources include solar, wind, geothermal, biomass, and hydropower. Solar energy, or the energy from the sun, is responsible for most of the energy on Earth. The sun produces this tremendous energy as a result of nuclear fusion occurring in its interior. During nuclear fusion, hydrogen atoms combine to form helium atoms. Every time hydrogen atoms combine to form,
notice now that this new atom has 2 protons and 2 neutrons, like a helium. And the original atoms, back up here just 1 second. The original atoms, they each had 1 proton and 1 neutron. So with 1 proton, they were hydrogens.
Every time hydrogen atoms combine to form helium atoms, a great deal of energy is released. This energy radiates out from the sun in all directions. Actually, only a very small part of that energy, about 1/1000th of the radiant energy released from the sun, strikes our atmosphere and planet. Yet that solar energy is critical to the survival of all living things on our planet. Solar energy drives the food-making process of green plants, called photosynthesis. Green plants take carbon dioxide from the air, water and minerals from the ground, and the light of the sun, and in the presence of chlorophyll in their leaves, produce food in the form of sugar or glucose. In addition, the plant releases oxygen as a byproduct of photosynthesis.
So the plant is storing energy from the sun as chemical potential energy in the sugar or glucose. It's this chemical potential energy that's released in fossil fuels, is released when we eat the food. It's the example we have with the charcoal when that became a fossil fuel and is burned.
So in many respects, all living things on Earth owe everything to the light from our sun. Many homes take advantage of solar energy by facing their windows in such a way as to take advantage of the thermal energy of sunlight to heat rooms naturally.
This is called passive solar heating that you have, and it's called passive because you haven't done anything special to collect the energy as it's shining through the windows.
A solar cell can be used to convert sunlight directly into.
This is called active solar collection. So, you actually are actively doing it. You make a solar panel to actively collect the solar energy. So, the example of this airplane.
Into electricity. Solar panels on this experimental aircraft power the electric motors that enable it to fly. Wind turbines can be used to generate electricity. The wind turbine spins in the air and is connected to a generator, which produces electricity. This is a very clean method for generating electricity. There is no waste product, and the only requirement is a steady movement of air provided by the wind. Geothermal energy. Geothermal energy is the energy of the Earth.
Geo means earth, thermal energy.
Geo means Earth, and thermal means heat. This energy is created about 4,000 miles or 6,400 kilometers beneath the Earth's surface. Temperatures are extreme at this depth. Wells can be drilled to pump water heated by this energy to the surface to be used at geothermal power plants. This hot water is used to change water into steam to spin turbines and generate electricity. The active geothermal areas are found around plate boundaries. This is where earthquakes and volcanoes occur. Geothermal energy is considered to be a renewable energy source because the interior of the Earth is always hot, and all that is needed is a supply of water so that steam can be formed. Biomass is anything that was once alive. Wood, agricultural crops, and animal products are all examples of biomass. Biomass gets its energy from the sun. Through photosynthesis, plants make sugars. These sugars are used as fuel by living other things. The energy stored in plants can be used as fuel. For instance, before 1850, wood burning was the main method of heating homes and cooking foods. Today, wood burning represents a small part of the energy sources in the United States. Another biomass source of energy through burning is garbage. Garbage can be burned to generate electricity in a plant called a waste-to-energy plant. Garbage produces only about one-fourth the energy that an equal amount of coal produces. But there seems to be an endless supply of garbage, whereas coal is a non-renewable resource. When dead animals and plants decay, they give off a gas called methane. Bacteria are responsible for this decay. Methane is a good source of energy. At landfills, wells are drilled to capture the methane gas given off by the garbage and decaying waste.
So as the trash and stuff decays in here, they capture the methane gas that's released. They use that to burn, make thermal energy, make steam to turn a turbine, to turn a generator.
If yeast, which is bacteria, is added to biomass, a fuel called ethanol can be made. This process is called fermentation. This fuel can be mixed with gasoline to power automobiles. Hydropower is the use of running water to generate electricity. A hydropower dam can be built on a river. A reservoir can be used to store the energy. Opening and closing gates can control the flow of water through the dam. Turbines in the dam turn when water rushes past them. The turbines are connected to the drive shafts of generators, which generate electricity when they spin. This is the least expensive method for generating electricity. Throughout the world, it accounts for 25% of the electricity produced. In the United States, it accounts for between 5 and 10% of the electricity produced. It is non-polluting, and because our water is constantly replenished through the water cycle, there is no threat of it disappearing as an energy source.
The entire goal of power plants, renewable energy resources, is to produce electricity. Now, electricity is one of the most useful forms of electricity that people have. It can be transported long distances. And then, remember, we were talking about energy conversions. Electricity can really be turned into all the other forms of electricity. We can take it and we can produce it into chemical potential energy. If you have enough electricity, you can actually make oil. Like when you go to the auto parts store and you see synthetic oil, they start off with natural gas and then they bond it together using electricity. You could you turn it into thermal energy, you can turn it into mechanical energy, you can turn it into electromagnetic energy, sound energy. So it's very, very useful to us. And most is due to a spinning turbine that turns an electric generator. So as I kind of explained before, anytime there's a magnet turning inside of a coil of wire, it'll spin and turn and make electricity. So the energy conversion is mechanical energy of the spinning turbine to turn the generator and make electricity energy. Okay, so we produce heat to get moving steam. So whether it's fossil fuels, nuclear power plants, geothermal, or biomass, all of these things, the goal is to have a source of heat, burning the fossil fuels, splitting the atoms to get heat from the nuclear reaction, pumping the water down to the earth, to the magnet, and to get the heat to make the steam, or burning the methane from the trash dumps so that you can get the steam. So all of it is to get the heat to make the steam, and then it uses the steam turns a turbine to turn the generator. Okay. So the production of steam in a regular power plant. Okay, chemical potential energy turns to thermal energy when it's burned. And the thermal energy is changed to mechanical energy as the steam spins a turbine. And then the turbine turns a generator, which produces electricity. And that turns mechanical energy into electrical energy. And that electrical energy is sent out to us, the customers. We can then I said, electrical energy is just incredibly useful to people. We can convert electrical energy into thermal and things like our ovens, mechanical energy, things like that move, like fans, like really anything in your house is moving. Okay, light, electromagnetic, sound. So it can really be turned into all the other forms of energy, which is why it's so useful. And we can transport it without too many problems just through electrical wires. So let's look at how electricity is produced in a fossil fuel plant. Okay, this one is using coal, but it really could be oil or natural gas. The same thing happens, the same steps. Okay, you burn the coal, the oil, or the natural gas to get thermal energy. The thermal energy is used to heat water to make steam. The steam spins a turbine. The turbine spins a generator. Okay, so again, you have this, basically it's a spinning magnet in a coil of wires. And when it spins inside a coil of wires, it makes electricity. The generator makes the electricity and it's sent out to the customers. And then nuclear energy, about 20% of the electricity in the United States comes from nuclear energy. Lake Anna, right here in Louisa, is a nuclear power plant. It uses nuclear fission. We would like to be able to use nuclear fusion someday, but right now we can only use fission. This process is used in power plants to produce uranium. It starts off with uranium-235, and then it's bombarded with neutrons. And so the nucleus is big enough with all those positive protons in there that, like charges repel. So it's kind of at the tipping point where the nucleus is unstable. And so when you hit it with another atomic particle, it'll break. So the neutron splits the atom, releasing a lot of thermal energy. And it also releases 2 additional neutrons that go and hit some other uranium atoms, and it starts a chain reaction. These neutrons put more atoms in chain reaction, releasing a lot of heat. Okay. Nuclear power plant or nuclear reaction, nuclear power reactor. So it's the reactor where the reaction is going on, is the place where the fission occurs in the power plant. Okay. And the fuel rod is the uranium-235. Okay. And we have the ability to split the atom. Then they put control rods in here. And the difference between a power plant and a bomb are these control rods. So basically they're lead rods that they stick down in there and they absorb some of the atomic particles so that they can control this chain reaction so that it doesn't get out of control. Okay. The reactor gets very hot because of the nuclear fission going on. So you need a cooling system that's used to cool the reactor. In our case, that's Lake Anna. Okay. So it doesn't melt down and overheat. Okay. The steps to making electricity in a nuclear power plant are identical to those making them in a fossil fuel plant, except for the source of heat. Okay, fuel source, uranium-235, is splitting using a neutron to produce thermal energy. So in a fossil fuel plant, this is where you burn the fossil fuels to produce thermal energy. And from this point on, it's the same. Okay, so we have nuclear energy to thermal energy, and the thermal energy is used to produce high pressure steam. High pressure steam is used to turn to mechanical energy because it's going to spin the turbine, and the turbine spins the generator, and the spinning generator turns it, the spinning turbine turns the generator to make electricity. So this is mechanical to electrical. Okay, so let's go over the steps here in a power plant, a nuclear power plant. Okay, so we split the atom to get a source of thermal energy. Thermal energy is used to produce steam. The steam is used to spin the turbine. The turbine is used to spin the generator. The generator produces the electricity and it's sent out to the customers. So if you notice, these steps are exactly the same as they were in a regular fossil fuel plant, except for this first step where it was the source of heat. And in one of the geothermal plants, it's the same. The only step that's different is the source of heat is the magma. So you would pump the water down to the magma or the lava, to boil the water, to get steam, to turn the turbine, to spin the generator, to make the electricity. Okay, before we move on to the next page, there's a short video I want you to see. Bill and I is going to take us inside of an actual nuclear power plant, and we'll be able to see where these actual steps take place.
This is the Columbia Generating Station, the only nuclear power plant in the Pacific Northwest, but there are 103 nuclear power plants in the United States operating today. The big tall building's the reactor, the big lower building is the generator, and the round buildings near us are the cooling towers to keep the steam going through the electrical generating cycle. At a nuclear power plant, everybody who comes in gets checked out by guys like these. It's a pretty secure place. Under here is the reactor. 30 meters.
Okay, so now Bill's going to take us through the process of generating electricity using nuclear energy.
Meters down, when the reactor's running, there's uranium fuel making heat. This is a classic demonstration of a nuclear chain reaction, the kind of reaction we have in a nuclear reactor. The mousetraps represent uranium atoms that we get by digging up ore from the ground, and the ping pong balls represent the subatomic particles called neutrons. Now, to start a chain reaction, we bombard the uranium atoms with extra neutrons, or in this case, an extra neutron. The reason this nuclear chain reaction is possible is because uranium has the rare ability to absorb a neutron, which will make it split or fission into smaller fragments. As uranium splits, it releases a lot of energy in the form of heat. It also spits out a neutron of its own, which can bombard a neighboring uranium atom, which then itself fissions, releasing heat and sending out another neutron, and so on.
Now, they have control rods to nuclear reactors to absorb some of those excess particles to keep the reaction under control.
And so on. In the reactor, the heat created by fissioning uranium heats up water, making steam. This high-pressure steam blows on the propeller blades of a turbine, which spins the shaft of a huge generator. Now, in the generator, a coil of wire is spinning in a magnetic field, which makes electricity. So it all boils down to this. The reactor, the steam, the turbine, the fuel, everything is set up to drive this big generator. It turns 30 times a second and makes electricity for close to 3 million people. It makes 1.2 gigawatts. It's a lot of juice.
Now, notice how that process was exactly what we put in the notes. The nuclear reaction releases heat. Thermal energy is used to produce steam. The steam spins the turbine. The turbine turns the generator. Okay, the problem with nuclear fission reactors, like the ones that we use, is they have radioactive byproducts, radioactive material that has to be stored for thousands of years, or basically forever. Okay, because it's very deadly and it's hard to store. Someday we would like to be able to use nuclear fusion, which is what happens on the sun. The only byproduct is helium, which is what we put in the birthday balloon, so it's really harmless. Okay. Right now it gets too hot, and it also requires too much energy to sustain it in small reactions. So we're not able to control this on Earth. Okay, so it's not cost effective right now. This is also known as reaction as fuel for stars like our sun. We're going to stop here. I want you guys to answer these questions on your own. When we come back next time, we'll pick up here.